Next lecture, now we will take one more example. A refrigerating machine having 8 TR capacity works on ideal Bell-Coleman cycle. The pressure of air entering the compressor is 1 bar and corresponding temperature is 20 degrees Celsius. The highest pressure reached in this cycle is 6 bar. The air after compression gets cooled to 40 degrees Celsius before entering the expandant cylinder. Assuming the compression and expansion be adiabatic or gamma is equal to 1.4, calculate the COP of a cycle. Second, mass flow rate of a refrigerant. Third, power required. And fourth, piston displacement of a compressor. Bore and stroke of a compressor. If the compressor uses double acting and runs at 30 rpm. Now first we will read this problem carefully. The refrigerating machine having 8 TR capacity. The machine is there and its capacity is 8 TR. Works on Bell-Coleman cycle. The pressure of air entering the compressor means P1 is equal to 1 bar and corresponding temperature is 20 degrees Celsius. Means T1 is equal to 20 degrees Celsius. The highest pressure reached in the cycle. Highest pressure means P2 is equal to 6 bar. The air after compression gets cooled, means cooling process is there before entering the expansion cylinder, means T3 is equal to 40 degrees Celsius. And here the expansion and compressions are adiabatic and you have to calculate the following parameters. First we will draw the PV diagram. 1 2 3 4 1 to 2 compression, 2 to 3 heat rejection, 3 to 4 isentropic expansion, 4 to 1 constant pressure heat addition. Now P1 is given and T1 is given. P1 is equal to P4 is equal to 1 bar and P2 is equal to P3 is equal to 6 bar. Now the initial temperature T1 is equal to 20 degrees Celsius. So 20 plus 273 is equal to 293 Kelvin and the entering before the expander is 40 degrees Celsius, means 313 Kelvin, and the processes are adiabatic process, means gamma is equal to 1.4. Now the capacity of refrigeration system is 8 TR. 8 TR means how much? 8 multiplied by 3.5 is equal to 28.136 kilojoule per second or 28.136 kilojoule per second or kilowatt. Now they have to ask the COP of a cycle. So here T1 and T3 are given, so you have to calculate the T2 and T4. So by using the 1 to 2 process is the isentropic process. So T2 upon T1 is equal to P2 upon P1 raised to gamma minus 1 upon gamma. So therefore T2 is equal to 6 upon 1 into 1.4 minus 1 divided by 1.4. So therefore T2 is equal to, P2 value is 6, the P1 is 1, gamma value is 1.4. So after simplification the value of T2 is equal to 488.67 Kelvin. Now T3, similar 3 to 4 process is again isentropic process. So for isentropic process T4 upon T3 is equal to P4 upon P3 raised to gamma minus 1 upon gamma. T4 we have to calculate. T3 the value is given 40 degrees Celsius. So 330 into P4 is 1, P3 is 6 raised to 1.4 minus 1 divided by 1.4. So after simplification the value of T4 is equal to 187.59 Kelvin. Now you can do the COP by both ways. Means you can directly write the formula for COP. COP is equal to T1 minus T4 divided by T2 minus T3 minus T1 minus T4. All four temperatures are known, so you can directly put their values and find out the COP. Otherwise, we will discuss next method as above. Now the COP form calculation we have to done here. Now COP is the ratio of refrigeration effect divided by work net input. Now here work done is calculated as heat rejected minus heat absorbed. So during process 2 to 3 heat is rejected, and during process 4 to 1 heat is absorbed. So work done is equal to heat rejected minus heat absorbed, means Q2 minus Q1. So heat rejected during 2 to 3 is Cp into T2 minus T3 into heat absorbed is Cp into T1 minus T4. The Cp is common, taken outside the bracket. The value of Cp is not given here, but we know the value 1.005 kilojoule per kg Kelvin. So T2 is 488.67, T3 313 minus T1 is 293, T4 is 187.59. So after this, the work done per kg is equal to 70.81 kilojoule. 70.81 kilojoule. Now this is the work done. Now the capacity of refrigeration system is given 8 TR. But what is the actual refrigeration effect which we will give? So therefore the actual refrigeration effect, now refrigeration effect is observed during process 4 to 1. So therefore Cp into T1 minus T4. So therefore refrigeration effect Cp is 1.005, T1 is 293 minus 187.59. So therefore refrigeration effect per kg is equal to 105.44 kilojoule per kg. Here please remember this, the capacity is 8 TR, means 28 point something kilojoule per second, but actually we are getting the refrigeration effect 105.54 kilojoule per kg. Now the COP is equal to refrigeration effect divided by compressor work. So the refrigeration effect is 105.54, which is actual refrigeration effect, and work done is 70.81. So the coefficient of performance for a Bell-Coleman cycle is 105.44 divided by 70.81. So the COP value is 1.496. COP is 1.496. So you can check by both way. You can take the formula for in terms of temperature, as well as you can do in this way. So both the methods, hope you have understood this. Now COP is known, calculated. Next term that we have to calculate, that is mass flow rate of refrigerant. Now mass flow rate of refrigerant is what? Means your actual capacity is 8 TR and your actual effect is 105.44. So therefore mass flow rate is equal to refrigeration capacity in kilojoule per second divided by actual refrigeration effect in kilojoule per kg. So therefore mass flow rate of refrigerator is equal to 28.136 divided by 105.44. So mass flow rate is equal to 0.266 kg per second to 0.266 kg per second. Please note this formula to calculate the mass flow rate. Capacity of refrigeration system divided by actual refrigeration effect. So two things that we have calculated. Next we have to calculate is power required. As COP is known, COP is the ratio of refrigeration effect divided by work input or power required. So actual refrigeration capacity is 8 TR. So power required to drive the refrigeration system is 8 TR. So COP is equal to refrigeration capacity divided by coefficient of divided by power required. But power required we have to calculate here. So power required is equal to refrigeration capacity divided by COP. So the refrigeration capacity you can take in any term. If you take in TR, you will get a power in TR. If you get it in terms of kilojoule per minute, you will get power in kilojoule per minute. If you take refrigeration capacity in terms of kilojoule per second, you will get the power in terms of kilojoule per second. So here we will take the refrigeration capacity in kilojoule per second. So 28.136 divided by COP is 1.496. So after simplification, the power required to drive the system is 18.81 18.81 kilojoule per second. Now next we have to calculate the piston displacement. Piston displacement means what? Volume. So piston displacement is, we know the formula, Pv is equal to mRT. So for initial position, the P1 V1 is equal to mRT1. So V1 that we have to calculate, so therefore V1 is equal to mRT1 divided by P1. M is the mass flow rate of refrigerant, R is the gas constant, T1 is the temperature, initial temperature, and divided by P1 is the initial pressure. So therefore V1 is equal to 0.266 into 287 into 293 upon 1 into 10 raised to 5. 1 bar is given. So for conversion into the Newton per meter square, we are multiplying by the 10 raised to 5. And here in joules it is taken 287. So therefore volume or piston displacement is equal to 0.2237 meter cube per second, because mass is taken in terms of kg per second. So therefore volume is equal to 0.2237 meter cube per second. Now one more addition term that they have given, bore and stroke of compressor. If the compressor is double acting and runs at 30 rpm, and they are given as bore is equal to stroke, that we have to calculate now. So here the piston speed is given, 300 rpm is given, and the piston cylinder is a double acting cylinder. So double acting stroke volume V is equal to n into pi by 4 d square into L into n, where d is the diameter or bore, L is the stroke, n is the rpm speed, and n is the number of acting. Here double acting is there, so therefore n is equal to 2. Now the speed is given in terms of rpm. Now we have to convert that speed in terms of rps. So therefore volume is calculated 0.2237, that is the stroke volume. The number of double acting cylinders, so n is equal to 2 into pi by 4 into d square. But here they have mentioned the bore is equal to stroke, so you can put L is equal to d. So d square into d into speed is 300 rpm. So therefore that bore of a cylinder is equal to 0.3054 meter. The bore of a cylinder is 0.3054 meter. So therefore as they have this given, bore is equal to stroke, so therefore stroke is equal to 0.3054 meter. So such the variety of examples can be asked on the Coleman cycle. So please do not stuck with a simple COP and refrigeration capacity, because in many cases they have asked about the power required, bore, stroke length. So these are the additional points. Hope you have understood this point, because this Coleman cycle is definitely there is one question on this Coleman cycle in every exam. If you look at the regular as well as the backlog papers, you will observe a one numerical on this Bell-Coleman cycle. So hope you have understood this point. Next we will discuss in the next part.